Do we know what dilations are? What happens to a figure when we dilate it? It either gets bigger or smaller. Now, so that's where the definition of dilation comes in. It changes a figure's size, but not its shape. So if it's a triangle, it's still going to be a triangle, just a bigger or smaller version of that same one. Similar figures, which we're going to get to later, and that's going to be the more important of this stuff, have the same shape but a different size. The scale factor is the ratio between the sides. In other words, what you multiply the sides of one figure by to get the second. Make sure that you know that right there. I'm telling you today, it's going to be on a quiz and a test later. That right there. If the scale factor is greater than 1, figure is going to get bigger. If the scale factor is 1, what happens when you multiply by 1?
Stays the same.
Stays the same. If you multiply something by 1, it doesn't change. If the scale factor is between 0 and 1, it gets smaller. Now, when it's between 0 and 1, what do people normally think of? What kind of numbers are between 0 and 1?
0.5.
Fractions and decimals. All right. The problem I have with saying a fraction is 2/3 going to make it bigger or smaller? Smaller because it's between 0 and 1. But if I turn around and say, well, I'm going to do 5/3,
It's bigger.
that's bigger than 1.
1.
So even though it's a fraction, that's going to make it get larger. All right, so don't just get in your head that it's going to be, oh, if it's a fraction, it's making it smaller. Fractions can make it bigger if they're bigger than 1. All right, graph those two figures on the same graph. All right, so when I start graphing this first one, figure 1 is 3, 2. And then 3, -2. -3, -2. All right, so here's my figure 1. Then I go to figure 2, which is 6, 4. Is that a dilation of the first one?
Isn't that a dilation of 2?
Well, first of all, is it a dilation, yes or no? Yes. What you're talking about is the scale factor. That's what we got to get to next. Once we figure out, yes, it's a dilation, it looks exactly the same, it's just bigger or smaller, then we need to say, what is the scale factor? The way to find the scale factor is very simple. If you can take everything in the first thing and multiply it all by one number and get the numbers in the second thing, there's your scale factor.
That's that.
All right. So in this case, the scale factor would be 2 because I take 3 times 2 and get to 6. 2 times 2 and get to 4. 3 times 2 is 6. 2 times -2 is -4, so on down the line. If you can multiply every number in the first and get something in the second, then that's your scale factor, and you know it's a dilation. All right, do these without, you don't have to graph these. I know it says graphing. Tell me if these are dilations based on the numbers. Is figure 2 a dilation of figure 1?
Yeah.
Is figure 3 a dilation of figure 1?
No.
Guys, is figure 4 a dilation of figure 1? If it is a yes, write down what the scale factor is. Don't say it out loud. Write down what the scale factor are if it works. All right, I'm going to graph these real quick. There's my original figure 1. So when I go to figure 2, all right, there's figure 2. Is figure 2 a dilation of figure 1?
Yes.
Yes. So yes, it is. The scale factor is 2. I can take the first figure, multiply all those numbers by 2, and I'm going to get every number in the second figure. All right, go to figure 3. 2, 1. All right, is that one?
Yes.
All right, if we say yes, then what's the scale factor? It can't be 2 because there's scale factor 2. Second. 1/2. The way to do it is this. take the second numbers and divide it by the first numbers. For example, if I do 2 divided by 4, what do I get? 1/2. If I do 1 divided by 2, what do I get? 1/2. There's your scale factor. If it's the same number every time. What some people like to do is they say, well, I'm dividing by 2 every time. If you divide by 2, that's the same thing as multiply by 1/2. If I divide by 3, that's the same as multiplying by what? Listen to what I just said. If I divide by 2, that's multiply by 1/2. If I divide by 3, that's multiply by 1/3. If I divide by 5, multiply by 1/5. Divide by 10, multiply by 1/10. It's the same thing over and over again. All right, so figure 3 works. Go to figure 4 over here. That is 4, -4. Excuse me, 4. All right, is that one? You should be able to look at the graph and say, no, it's not. How do I know it's not?
Because it's a square now.
Because it turned into a square versus a rectangle, what we started with. Now, using the scale factor rule stuff, well, let me back up. If you say no, there is no scale factor. So if you ever say no on a dilation, you cannot have a scale factor. How do I know looking at the numbers that it won't work?
Because it's got the same number as the first one.
What did I do right here from this 4 to that 4?
Nothing.
Nothing. I multiplied by 1. But then this one was 2 to 4. One of them changed and one of them didn't. That can't work. All right, so look at this one. It says, is figure 2 a dilation of figure 1? So which one do we need to start with?
Figure 1.
Figure 1. Find the numbers for figure 1 and write those down. So if I was doing this one, figure 1, my points are 0, 2, 2, -1, -2, -1. Then I'm going to go to figure 2. Go in the same order on the points. Where did I start at? 0, 2 was right here. So I'm going to start with that same point on the other triangle. That's 0, 4. Go to the next point. So this one is 4, -2. And then the last one is -4, -2. Is figure 2 a dilation of figure 1? What's the scale factor? Yes or no?
Yeah.
Can I multiply these numbers by the same thing and get these? I can't.
Yeah, you can.
2 times 2 is 4. 2 times 2 is 4. -1 times 2 is -2. -2 times 2 is -4. Looks to me like we can. So that, yes, it's a dilation. Scale factor is 2. All right, that one's yours right there. All right, again, if it says it's figure 1 a dilation of figure 2, we need to start with figure 2. Give me my points for figure 2. All right, 0, 0. Say again. 9, 0. 6, 3. Go in the same order for figure 1. 0, 0. 3, 0. Can I take figure 2 and multiply it by something and get figure 1? What? I can't multiply figure 2 by 3.
Multiply by 1/3.
I can divide by 3.
Or divide.
And if I divide by 3,
You're multiplying by 1/3.
I'm multiplying by 1/3. We need to understand that part right there. What is happening from figure 2 to figure 1? What's happening to the triangle? Bigger or smaller? It's getting smaller. If it's getting smaller, the scale factor has to be between 0 and 1. That should be a clue to you that you're dealing with a fraction. So, read the question, see which one you're supposed to start with. Do that one first, write down the other one, see if you can multiply or divide, and get your scale factor. All right. Corresponding simply means they are in the same spot of each figure. So get that copy down. We'll get filling it in. All right, corresponding simply means we're in the same spot on different figures. So if I said, which one corresponds to A? Which one is in the same spot? It looks like D, but it's not, and I know it's not because of why. What do these little marks mean right here? That means they're the same.
It's F.
So the angles that are the same have to be in the same spot. What happened to this figure? What did I do with it?
You just turned it.
It's reflected. All right. So I know that angle A matches angle F. Those you put as equal. Angles are going to be equal on corresponding. Well, angle B corresponds and is equal to which one?
D.
Angle D. They've got the same marks. That leaves angle C being equal to angle E. When it comes to corresponding sides, the sides are not equal. They just correspond to each other, meaning they are in the same spot. When I name a side, how many letters do I use? 2. So if I said AB, notice I'm not putting an equal to. Don't put them equal to each other on corresponding sides. Which one does AB match up with? It's very easy to do it. Follow the angles. I went from the 1 mark at A to the 2 marks at B. Do the same thing over there, and you get FD. So if I wanted to mark or say which one corresponds to BC, which one corresponds to BC?
DE.
It's got to be DE, right? What did I do on BC? I went from the 2 angle to the 3 angle. So I've got to go from the 2 to the 3 over there. That leaves AC. Which one does it match up with? Which things are equal? Which things are equal? The angles are going to be equal. The corresponding angles are going to be equal. The sides will not be equal.
Can't you put CA too?
Yeah, on all of these, you could say AB or BA. You could say FD or DF, and you're still talking about the same thing. All right, copy those down. We'll show you what to do on those. If it tells you that figures are similar, whether it's triangles, rectangles, it doesn't matter. And it tells you to find missing sides. First thing you got to do is find which ones correspond to each other. What corresponds to that 12?
X.
The X. What corresponds with the 8?
4.
The 4. So when I start doing this, I know that the 12 has to match up with the X and the 8 has to match up with the 4. So I'm going to say 12 over X. You make a fraction with the corresponding sides. And that's going to equal 8 over 4. Where did I start with both of the fractions? Which triangle? Big or small? If I start with the big triangle the first time and it goes in the top of the fraction, then the second fraction has to have the big number in the top on it. Now I could have done this and said, well, I want to start with the small triangle. Say I start with the 4. Which one does the 4 correspond with? It corresponds with the 8. If I start in the small triangle, I come back to the small triangle, I can do X over 12. Doesn't matter as long as you set it up. If you go big to small both times, you're fine. If you go small to big both times, you're fine. How do I solve a proportion like this right here? What do I do? Cross multiply and divide. So what is 8 times X? 8X. And then I've got 4 times 12. So then 8X equals 48. Divide by the 8. You get 6 for your answer. I'm going to work this other one out. Same process. I get 8 times X, 4 times 12. Nothing changes. You still get 6. So it doesn't matter which way you work it out, as long as you go in the same order when you set up the triangles or fractions. Now, look at this second triangle, or second set of triangles. It would probably be in your best interest to redraw the triangles so that they look the same. Notice how these first two, they look exactly the same. I would probably take this one and redraw it so that it looks like that one. Now, when I do that, what did I do with this from here to here? What did I do? I reflected it. So where does that 5 now go? On the left side over here. This 4 stays in the bottom. To me, this is a lot easier to set up than the other way. If you can do it the other way, have at it. I don't care. All right, give me a fraction that would work. The 6 corresponds with the what? 4. So I can do 6 over 4.
And then x over 5.
And I can do x over 5. So then I would cross multiply. 4x equals 30. Divide. You get 7.5. Do not be shocked when you get decimals. You will get decimals on these.
Okay, so
Find the sides that correspond with each other. Write fractions based on those sides. So the 6 corresponding with the 4, I write my fraction 6 over 4. Go back to the big one, x over 5. Cross multiply, divide, get your answer. All right, to do this one, we're going to rotate my angle that's marked here has to match that one. Where does that 4 go?
Right there on the left side.
All right, so 4 goes there, which means my 8 now rotates to the top and the 10 rotates over there. You should be able to solve it from there. All right, so I've rotated my triangle to make it look the same. Which one do I have to have in there? The x has to be in there, so I'm going to do that one first. X matches up with the 10 in the second triangle. This one corresponds to that. After that, I can pick either of the other pairs that work. If I choose the 20, 20 matches what?
8.
Or I could have said, well, I'm going to do x over 10, and I want to use the small numbers to make it easier on myself. If I use the small numbers, I would say 10 over 4. The 20 matches the 8. The 10 matches the 4. You have to have the x in there, and then pick one of the other pairs if it gives you more than you need.
So do we do the other one now?
So finishing this one, I would get 25. If I choose to do the 10s here, I would have 4 times x equals 10 times 10. So 4x equals 100. Divide and get 25. Again, it doesn't matter which way you do it. You're going to get the same answer as long as you set it up right. All right, second one's yours. All right, which one do we want to rotate? First one, second one. All right, I'm going to rotate the big one. Again, make sure that the angles wind up in the same spot. So if I rotate this and turn it, that 7.5 comes over here. The 18 is now there, and the 15 goes to the bottom. It is extremely important that you go in the same order both times. Because if you don't, it's going to mess you up. I know the x has to be in there. What does x correspond to?
18.
Now choose your other ones.
7.5 or 5.
It's 5 over 7.5.
If I do x over 18, based on what I did, I went small to big.
Okay.
Then I've got to go small to big the second time.
I would big.
I'm just going to do the 5 over 7.5 because y'all won't do it because you see that one and you don't want to use it. I'm just going to show you how easy it is and it'll work. 7.5 times x is that. 5 times 18 is 90. Divide, and you get 12. If you used the 10 over 15, you would have got 15x equals 180. You still get the 12 at the end.
Oh my God. Oh crap.
All right, so when I do this, I'm going to redraw this big one over here. Make sure the angles match up. The 9, when I reflect, will come to the left side. X will be on the top and the 12 will be on the bottom. So then, once I have this, I know that these two have to be in there. Which way you write it depends on what you want to do. Let's do 7 over x for this one. If I do 7 over x, I've got 2 sets of sides, 2 pairs that'll work. It doesn't matter which one you choose as long as you go in the right order. So since I did 7 over x, small triangle to big triangle, I would have to use the 6 and the 9. Or 8 and 12 right there. So I would cross multiply, get 6x equals 63.
When you get X, you should get 10.5.
10.5. And again, what do I know about this x compared to 7? Should it be bigger or smaller? I'm going to the bigger triangle, so this number should be bigger than that 7 it matches up
Well,
with.
wax it into rotate.
If you are having trouble setting it up and it gives you angles, here's a way to make sure you do it right. The 7 is in between that 1 and the nothing. Alright? So when you redraw triangles, it would have to be in that same spot. Does that make sense? So like here, the x is in between the 1 and the nothing. It's got to match the 7 because it's in between the 1 and the nothing. The 6 is in between the 1 angle and the 2 angle. The 9 is in between the 1 and the 2 angle. Those have to match up. All right, so if I go to this second one over here, what do I need to do to it to make them the same?
You gotta put that bottom one all the way to the top.
This needs to be rotated. Whichever one you want to rotate is up to you. I'm just going to rotate the little one.
So it's gonna be the.
So
six
that
will still be
1
on the long side.
comes down there. The 2 goes up top. So I can do that without worrying about really what's going on.
The six.
Where's this 5 at?
At the
It's
bottom.
at the bottom.
It's in between the 1 and the nothing. Well, the 1 and the nothing is down here.
And the 4 on top is 6.
4 is in between the nothing and the 2.
So right there.
So it's got to be there. The 6 is in between the 1 and the 2. So it would have to be there. Right? You should be able to finish it from there. So based on what I've got, I know I've got to use the x and the 4. Tell me the other fraction.
5, 10.
I can't do 5 and 10. I can do 10 and 5.
I did 10 and 5. I did 10 and 5.
Because if I start here, that's the big triangle. I've got to start there the second time. So 5x equals 40. Divide by 5. Get x equals 8.
You can't do 12 6.
Yeah.
you can.
Yeah.
You can.
But you should still get 8.